The James Webb Telescope has revealed the clearest data ever obtained from Proxima Centauri B.
Is there another planet that's very close to Earth, kind of like us, where there could be a civilization?
Yeah, I mean, the closest star system to us, Proxima Centauri, actually has a fairly Earth-like planet around it. We don't know quite how Earth-like it is, but it's called Proxima B.
NASA has hit the jackpot this time. Okay, the Holy Grail is to find an Earth-like twin in outer space.
Unveiling brilliant lights that defy explanation. These mysterious signals may not originate from rocks or gases, but could hint at the presence of life or advanced civilizations. Scientists are in a race to determine whether these lights are natural or artificial. Stay tuned. This discovery could reshape our understanding of the universe. Are they signs of alien cities or simply nature's spectacle? Proxima Centauri B, the closest star system to Earth, has been under astronomers' scrutiny for years in the search for extraterrestrial life. When the James Webb Telescope turned its powerful infrared instruments toward the planet, it detected something astonishing. The data revealed an unusually intense glow, far brighter than what natural phenomena alone could account for. What could be behind this mysterious illumination? A discovery so profound it threatens to rewrite everything we know about the universe awaits its revelation. The speculation is wild. Some think these lights could be the result of an advanced civilization illuminating their world. Others are more cautious, suggesting that these anomalies might have natural explanations. But the idea of alien city lights is hard to shake off. It's like catching a glimpse of something out of the corner of your eye and not being able to look away. The James Webb Telescope's ability to detect faint light signatures is unparalleled, making it the perfect tool for this kind of investigation. Most space cameras struggle to pick up dim signals in the vast expanse of space, but Webb's advanced sensors can capture even the tiniest flickers of light. This capability allowed scientists to detect the strange brightness on Proxima Centauri B's night side, where the lights appear to shine like artificial sources. This isn't just about lights. Scientists are delving deeper to uncover the mysteries of this exoplanet. Proxima Centauri B, a rocky planet similar to Earth, lies within its star's habitable zone, making it a potential candidate for liquid water. Adding to the intrigue is its unusual heat signature. Typically, rocky planets absorb sunlight and emit infrared energy, but Proxima Centauri B's pattern deviates from the norm. With its ability to analyze heat emissions, the James Webb Telescope could reveal crucial details about the planet's atmosphere and surface. If an atmosphere is present, it could redistribute heat from the sunlit side to the darker side, acting as a thermal blanket. Without one, the planet would experience extreme temperature differences, with one side blistering hot and the other frigidly cold. By studying these temperature changes, astronomers can infer whether Proxima Centauri B has an atmosphere, and if so, what it might be made of. What's more, the James Webb Telescope's orbit aligns almost perfectly with Proxima Centauri B's 11-day rotation period. This means scientists can closely observe the planet's day and night cycles, giving them a clearer picture of how its climate and surface behave over time. If Proxima Centauri B has an atmosphere, the next step is to study its chemistry. Scientists are searching for signs of life-friendly gases like oxygen, methane, and water vapor. These elements could hint at the planet's potential to support life. But here's the catch. Even with its advanced capabilities, the James Webb Telescope faces challenges. Detecting bound oxygen, a key indicator of life, is tricky. Fortunately, it can pick up on other markers like ozone, which also points to biological activity. Despite these limitations, Webb's infrared sensitivity gives scientists a powerful tool to study distant worlds in ways they've never been able to before. The discovery of Proxima Centauri B has ignited a wider conversation about the future of space exploration. While the James Webb Telescope is a remarkable tool, its reach is limited to studying a select number of planets within a certain distance from Earth. Scientists are already anticipating the next generation of telescopes, such as the Extremely Large Telescope, which is expected to begin operations in 2028. These ground-based telescopes will complement Webb's findings by offering even more detailed observations of exoplanet atmospheres. A key challenge in exoplanet research is distinguishing a planet's faint light from the intense brightness of its star. To address this, scientists are developing advanced techniques like internal masks and external starshade satellites, which block starlight and enhance the visibility of planetary reflections. These innovations will improve atmospheric analysis and aid in the search for signs of life. As exciting as these technological advancements are, they come with their own set of hurdles. One major challenge is distinguishing between gases produced by living organisms and those created by natural processes like volcanic eruptions. For example, finding methane on a planet doesn't automatically mean there's life. It could just as easily come from geological activity. Scientists have to be careful not to jump to conclusions based on limited data. The James Webb Telescope's observations have also highlighted how much more there is to learn about exoplanets. It has inspired discussions about other distant worlds, including their potential to host life or even advanced civilizations. This ongoing exploration keeps pushing the boundaries of human knowledge and technological innovation. Looking at the bigger picture, humanity's search for extraterrestrial life reflects a deep curiosity about our place in the cosmos. The James Webb Telescope has enabled us to see farther and with greater clarity than ever before. Even if the mysterious lights on Proxima Centauri be of a natural explanation, they have already inspired new ideas about how we might address some of our most profound questions. The search for life beyond Earth, whether microscopic or part of an advanced civilization, remains one of the most thrilling frontiers of science. The mystery of Proxima Centauri B lingers, but the next chapter reveals how humans and technology continue pushing the boundaries of space exploration in pursuit of new discoveries. Alien clues in cosmic shadows. The search for alien life isn't slowing down. Jill Tarter, known for her big ideas about space, believes new technology will finally crack the code. She dreams of a time when the whole world can join the search for alien buddies. Meanwhile, NASA's shiny James Webb Space Telescope might already be onto something. Rumor has it that it spotted city lights on a nearby planet. Imagine the excitement if that turns out to be true. The James Webb Space Telescope is like the superhero of space tech. It's built to answer some of the biggest questions about the universe. Using a camera and advanced filters, it breaks light into different parts, allowing scientists to figure out what stars, planets, and even whole galaxies are made of. By looking at the atmospheres of other worlds, the telescope is hunting for signs of life, even the tiniest ones. One mystery it's tackling is why there's more mass in the universe than expected. This hidden mass, buried deep in massive galaxies, gives us clues about how the universe looked billions of years ago. 2 decades ago, our knowledge of planets beyond our solar system was minimal. Today, astronomers have identified over 4,000 exoplanets orbiting distant stars. Yet, this is merely a fraction of what's out there. Scientists estimate that trillions of planets remain undiscovered. The search for extraterrestrial worlds has been full of surprises. A breakthrough occurred when the Galileo spacecraft detected a potential sign of plant life on another planet, the first ever discovery of a biosignature, an indication that life might exist elsewhere. This signal, called the vegetation red edge, reveals how light reflects off plant life. Advanced instruments like the James Webb Space Telescope, JWST, are now mapping planetary orbits and analyzing atmospheric compositions for signs of alien life. As sunlight filters through a planet's atmosphere, molecules absorb specific wavelengths, creating unique light patterns, like a cosmic fingerprint, that help scientists determine the atmosphere's makeup. The JWST could reveal if planets have Earth-like atmospheres filled with nitrogen, carbon dioxide, and oxygen. These are the building blocks for life as we know it. But strange chemicals, might mean life exists in totally unexpected ways. One wild idea is that finding certain chemicals, like chlorofluorocarbons (CFCs, could prove the existence of advanced alien societies. CFCs are man-made, used here on Earth for cooling and industry. If the JWST picks up these chemicals on other planets, it might confirm there's intelligent life out there. But life beyond Earth might not look anything like what we're used to. Temperate, Earth-like places aren't the only spots where life might thrive. Enter extremophiles, tiny organisms that thrive in harsh conditions. These tough little creatures survive in boiling heat, freezing cold, and even toxic environments. If life like this exists on Earth, who's to say it couldn't be out there, living on planets we'd consider uninhabitable? Planets orbiting red dwarf stars are particularly intriguing. These stars are cooler and dimmer than our Sun but have extraordinarily long lifespans, allowing ample time for life to develop. The James Webb Space Telescope JWST has brought attention to the Trappist-1 system, which consists of 7 rocky planets, sparking excitement among scientists. Notably, 3 of these planets lie within the habitable zone, where liquid water could potentially exist. Trappist-1 star is significantly smaller and fainter than the Sun, yet it emits just enough light to make these planets candidates for sustaining life. Located only 41 light-years away, this system is practically in our cosmic neighborhood. With the JWST, researchers are analyzing the star's light to determine whether the planet's atmospheres could support life. If conditions are favorable, these worlds may hold exciting possibilities. Even closer to Earth is Proxima Centauri, our nearest stellar neighbor at just over 4 light-years away. Also a red dwarf, this star was found to host a planet in its habitable zone, Proxima B, discovered in 2016. This planet is just a bit bigger than Earth and gets enough light to melt ice into water. But there's a catch. Proxima B's orbit is so close to its star that it faces intense solar winds and radiation. One side of the planet is always in daylight while the other is locked in darkness, a phenomenon called tidal locking. Despite these challenges, Proxima B gets just enough sunlight to keep its temperature in a range where liquid water could exist. If it has an atmosphere that traps heat, it might even support life. The idea of oceans and evolving creatures on Proxima B fuels scientists' imaginations. However, the planet's extreme conditions make it tough for life as we know it to thrive. Strong solar winds could strip away its atmosphere, leaving it barren. But let's not write off Proxima B just yet. Life, especially extremophiles, has a knack for surviving in the most unexpected places. If Proxima B has an atmosphere, it might shield potential life from harsh radiation. Even better, if it has oceans, life could start in water and evolve into something entirely new. The search for life on Proxima B and other exoplanets isn't just about finding extraterrestrials. It's about exploring the universe's possibilities. Could advanced civilizations have developed unimaginable technology to survive extreme environments? Perhaps they've constructed enormous solar panels to capture energy from faint stars or devised ways to illuminate the dark sides of their worlds. Meanwhile, scientists on Earth are working tirelessly to uncover more. The JWST plays a vital role in studying Proxima B and similar planets, analyzing their light to determine size, mass, and composition. Every breakthrough brings us closer to answering the age-old question, are we alone? The Proxima Centauri system presents challenges, such as intense stellar flares that complicate observations. Yet, the JWST remains unaffected, collecting invaluable data and images that deepen our curiosity. As we continue exploring Proxima B and beyond, the possibility of discovering alien life shifts from science fiction to scientific reality. The journey is far from over. Prepare to uncover new worlds, each offering its own fascinating secrets. Looking for new homes, back in 2016, the discovery of Proxima Centauri B stirred up quite the excitement. It was like finding a shiny needle in a galactic haystack, a planet that might just be Earth's distant twin. But since then, astronomers haven't stopped digging around the universe, and they've come across a bunch of other fascinating exoplanets. Some of these are oddballs, and others seem to tick the boxes for potential habitability. Kepler 442b is kind of like Earth's bigger sibling, weighing in at about 1/3 larger than our planet. This planet whizzes around its star every 112 days, making its years way shorter than ours. It's parked around 1,194 light years away from us,